Today's lesson is a continuation of section 2.1 using integers and rational numbers. There's a few other topics that go into section 2.1 we're going to start talking about right now. One of them, as I have it there at the top, is absolute value. This is also something the students, as 8th graders, probably have worked on at some point in the past. I'll usually see if they can, I'll ask them kind of questions to see if they can remember anything about absolute value before I put the definition on the board or before I start talking about it. Sometimes if I show a few problems, a few examples, like the ones I have up here for 1, 2, and 3, that kind of jogs their memory as well. They usually remember the lines around a number. And some can even tell me, well, I know the absolute value of -10. That's what this problem is saying with the two lines. The two lines mean take the absolute value of whatever number you get in the middle. The absolute value of -10 is 10. The absolute value of 45 is 45. And even this tricky one, this third one is saying, it's almost like solving an equation. It's saying, put some number in for x, take the absolute value of it, and you got to get an answer of 5. There's actually two possibilities that could work for this. If you put 5 in between the lines, take the absolute value of that, that would equal +5. Also, if you put -5 in between the lines, that also is a solution for that equation. So after me going through a few examples, sometimes they start to remember what absolute value looks like. In terms of giving me a definition, sometimes they can come up with it, sometimes not. But what happens with absolute value, the definition is the distance a number is away from 0. And we're talking about on the number line. So if I draw a little number line here, let's say here's 0 on the number line, and then I have 1, 2, 3, 4, 5, kind of like we talked about. I guess in this case it'd be -5, though I'm going to the left. The number -5 is 5 spots away from 0. 1, 2, 3, 4, 5. 5 spots away. So we'd say it has an absolute value of 5. The number +5, 1, 2, 3, 4, 5, also has an absolute value of 5. 1, 2, 3, 4, 5. It's also 5 spots away from 0. So again, that's why this question number 3 had those two possible answers. But anytime I'm just figuring out the absolute value of some number, it's just the distance that number is away from 0. If I look at number 4 here, you could see absolute value in amongst a problem you got to evaluate. This says take the absolute value of -5, which, as we talked about, is 5. And then you got to add 13 to whatever you get there. So in this case, that's going to be 18. Number 5 is something just a little different. Maybe students haven't seen before. They've seen the absolute value signs, and they know that inside of here, this means take the absolute value of -1/4. So what that should give them is just 1/4. But the only thing is there's a negative sign out in front of the absolute value. And so after talking about it for a little bit, we can usually realize that, well, absolute value means take the absolute value of -1/4, which would be 1/4. But then this negative says we got to apply that to our answer. So the answer ends up being -1/4. That is somehow, we talked about how you can still get a negative answer in a problem like that. Well, because you took the absolute value, you did what you're supposed to do, took the absolute value of -1/4, but then the negative outside out front says apply that to whatever you get once you took the absolute value. So in that case, we get -1/4. And then I put number 6 up here as just kind of like a trick question or just something to talk about too and see if they can figure it out. And some of you guys are able to. But this one, kind of like number 3, says put a number in for k, take the absolute value of it, and the answer has to be -29.2. When we're talking about absolute value, it's the distance a number is away from 0. And it usually ends up being a positive number because when we talk about distance, I usually mention this in class too, when we talk about distance, we talk about it in a positive way, like a positive amount of miles or feet or inches we traveled. I wouldn't say, I went, 7 miles to Plainview, -7 miles to Plainview today. I'd probably say I traveled 7 miles to Plainview, or if I'm going to the cities, I wouldn't say I traveled -80 miles to the cities or whatever it may be. I usually talk about a positive amount of distance. So when I take the absolute value of something, I got to end up with a positive answer. And so is there a number I can plug in for k and take that and get a positive answer, and then the answer ends up being -29.2. And after talking about it a little bit, we'll understand that, or start to figure out that this problem actually has no solution to it. If I'm going to, no solution. If I'm going to put a number in between the lines there, in between the two lines for absolute value. When I take the absolute value of it, I got to get the positive of that. Well, then there's no way I can end up with negative 29.2 then as a possible answer. So that one kind of a tricky one, but after talking about it for a while, sometimes one we can figure out with absolute value. This section will talk about absolute value, and it'll also talk about the opposite of a number. What does the opposite of a number mean? And sometimes this is one after we go through a few examples students kind of remember, but for now I'll put the definition up here. The opposite is the number that is the same distance away from 0 as the given number. And so you might ask a question or might get a question like, well, what's the opposite of negative 1,000? Students can usually figure out just from what they know about the word opposite already as an 8th grader that the opposite of negative 1,000 will be positive 1,000. Opposite of 57 will be negative 57. Opposite of negative 5.5 will be positive 5.5. So it's just kind of like flipping the sign of whatever number you have. Well, then take the opposite of that, the sign of the opposite number. So after talking about absolute value and opposite for a little bit, I'll show a few problems like this because in the book there'll be some like this in the assignment for today. It says for the given value of A, find, this means right here, this negative A, it means like you're throwing a negative sign in front of a number, which will give you the opposite sign of what you got. So that's a way to say the opposite. That's their way of saying in algebra, and kind of the algebraic way of saying find the opposite of whatever number they give you. And then we know the lines outside of that number is saying find the absolute value. So we're going to do both those things for these problems. And again, these are problems like you might see in the book. So I'm going to go through a few examples just to show you what they're looking for. This first one right here says A is negative 9.2. What I want you to do for these is they're asking you two different questions. They're saying what's the opposite of that number and then what's the absolute value. So you're going to answer the two different questions. What's the opposite of this number? Well, the opposite would be positive 9.2. Opposite of negative 9.2 is positive 9.2. Then it also wants you to figure out for this value A, figure out the absolute value. So I want you to put, there's going to be two different answers, so put a little semicolon between the answers. The answer for the first one was positive 9.2. Now say what's the absolute value. Oops, not with the line there, but now you're figuring out, well, what's the absolute value of negative 9.2? And in that case, that would also be positive 9.2. For some of these problems, they're getting the assignment, you might end up putting the same number twice, and that's okay. I still want you to put the same number twice because that shows me your answer in both questions, and you understand that, yeah, in this case, it is the same answer for both one. Look at number 2 here. A equals 15. I'm going to find the opposite of 15 for my first answer and the absolute value of it for the second answer. Opposite of positive 15 is negative 15. The absolute value of 15 is still just 15. So for this one, two different answers. And so again, part of the reason why I want you to list both those possible answers. There'll be some problems like this in the book today. So that's what they're asking you to do. So we went through some of those examples talking about absolute value and the opposite of a number. There'll also be some problems just evaluating a problem that may have absolute value in it. And we did a couple like this already, but looking at these first three here. Absolute value of negative 91. Again, it's the distance that number is from 0. So if I think of where negative 91 would be on the number line, it'd be 91 spots away from 0. And again, we talk about distance in a positive way, so 91 is the answer for that one. Absolute value of 6.5. is 6.5. It'll be 6.5 units away from 0. So 6.5 is the answer. And number 3, kind of like I had on the first page, absolute value in negative 6 is 6. And then plus 12, that gives me 18. So an absolute value, if it's in a problem, I can kind of evaluate it, and I tell students to kind of treat it like a parentheses. You got to find out what the value inside that absolute value is. You know, kind of like you have, again, the parentheses around number if it's a big problem. You got to find out what that number is, whatever you get. And then at the very end, you're going to take the absolute value. So here, I'm going to put an example. So even if you had something like 2 plus 3, and you had to figure this problem out, you'd have to find out what 2 plus 3 is, 5, and then you could deal with the rest of it. Same thing for an absolute value problem. If you have lines instead, let's say it's 2 plus 3, you have to take 2 plus 3 and get 5. and then take the absolute value of 5, and then that'll be your final answer. So absolute value, kind of treat them like parentheses. They're also like parentheses in the fact that you have to deal with them many times first before you can move on to some other part of the problem. A few other examples just to show what else you can get too. You may get a problem where we did this in chapter 1, but they might tell you, oh, x is -3, and then you have to put that number into the problem and then evaluate it. In this problem, if I put -3 inside the absolute value, I already have a negative in there, so it's like negative of -3, and something we'll talk about and maybe have heard, students have heard before, but if you have the negative and negative, you have two negatives there, a double negative, it makes that number positive, really is what happens. So really this is just talking about the absolute value of +3. Now both those negatives cancel each other out. So the absolute value of +3 is just 3. And then for this last one, this last example here, if I put -3 into the absolute value, it goes in there, and also it goes in next to the 2 here, something that's going to get multiplied by 2. Again, kind of like a parentheses. I have to deal with that absolute value first and find a value for that. Absolute value of -3 is 3. So now there's a 3 in my problem, +3 there. And then 2 times -3 would give me -6. 3 plus -6 is going to give me -3. So if there's an absolute value, those lines are in the problem. Again, kind of like a parenthesis, something you have to deal with probably first before you can move on to other parts of the problem. And once you take care of the absolute value, notice how in this problem right here, I took the absolute value in -3, and then I got rid of the parentheses in the next line, okay, or not the parentheses, but the lines. Once I took the absolute value in -3, in the next set, my next line of work there, those absolute value lines are not in there, okay. Once you've taken the absolute value, the lines are gone. Get those out of the problem. Sometimes I'll see students that hold on to those all the way through the problem until the very end, okay, but that's not right. Once you've taken the absolute value of a number, like we did here, again, kind of like parentheses, sometimes you have to do just kind of, once you have just a number in there, you take the absolute value of it, and then the line should not be in your problem anymore. You've done that part. So just like when you add stuff and then you don't have that addition sign still hanging there, or a multiplication sign. Once you've done the operation, get rid of those lines.